Yes, thanks. Raghu sir, Raghu sir, that how far it is working on that thing also is to be corrected. See, ah, so I told you that's a problem. I'll write I not, I'll put a dot, so this entire thing will go up. Is it, that also please check. Okay, so good afternoon everyone. If you remember, last time we were doing what are central forces, right? So, and we checked that if Coulombic force is a central force, we came out with the conclusion that yes, it is a central force, right? We had completed this, right? As much as I remember, we had completed this part. So let us go ahead now. Let's do some problems based on this. So let us say you have two particles, Q and Q of mass m and m, and then they are at a distance r from here, and this object is kept on a rough ground, right? What should be the minimum separation between them so that they remain stationary? So friction is mu, coefficient of friction is mu, right? So when they will be on the verge of motion, you have, let's say, a charge m here, and another charge is also m, right? So another charge is also m, right? And charges are q and q. So between them there will be attraction or repulsion. There will be repulsion between them, right? Because they are like charges. And what will be the repulsive force? F will be what? K q1 q2 means q into q divided by distance, which is r. That is the repulsive force, right? So this is the force acting on this charge which it wants to take away. Now this is the force, repulsive force. To stop this object from moving on the ground, which force will act on the left side? You know, friction will act on the left side, right? Call it Fr. And uski value, the value of friction is N into mu. That is a friction force, normal reaction into mu, right? And what is a normal reaction? You know, m is the mass, so the downward force is mg, and that will be mg into mu. That's a friction force, right? And minimum separation so that they remain stationary, right? So that they don't move. So when will they remain stationary? When your friction force and F balances, when Fr is equal to F, right? And Fr is how much? Mg mu, and that's equal to F, which is kq square divided by r square. So by equating them, we will get the minimum separation, means you have to find the value of r, and you can very well get the value of r from here. What's coming out to be mg mu, or rather r square will be equal to kq square divided by mg mu, and the value of r you can very comfortably get from here. That's what it is, kq square divided by mg mu. That's the minimum distance between them, right? Write down. Right, let's go ahead then. So there are two charges, Q1 and Q2, and a positive point charge Q1 is there, and there's another positive point charge. Guys, what will happen between positive charges? They undergo attraction or repulsion. So they are like charges, they will undergo repulsion, right? So find a force acting on Q1. So you have to find the force on Q1. And there will be repulsion force. So Q1 will experience force in this direction, right? And how much it will be? We already know the formula. F is equal to K Q1 Q2 upon R square, right? And R is nothing but this distance is R, right? And you know that this distance is how much? Well, that is A. That's A, right? And so you can find out R. How much is it? Under root A square plus A square, right? That gives you root 2A. That's very far. You put it there, you get the answer, right? Take it down. This will be so let us say that there are multiple charges. In this case, let's say Q1 and Q2 are there, right? So Q1 will apply force in this direction, right? How much will that be? K Q Q1 upon, let's say this distance is A divided by A square. Similarly, Q2 will apply force in this direction, and how much will it be? K Q Q2 divided by B square. Yeah. So these are the two forces acting. And what will be the net force? And there will be some, of course, some unit vector will be associated with it. Let's say A cap is here and B cap is here, right? So you have got two forces, and then you want the net force on Q, so it will be the vector sum, right? So you can call this force F1. So net force on Q is nothing but F1 vector plus F2 vector, right? And this is called by what I've written. Okay, that will come in the next page. So everybody understood this part? Net force will be the sum of the two forces, right? That's obvious. And this is called principle of superposition, which says that the principle of superposition states that every charge in space creates an electric force at a point which is, so you see, this F1 force, is it dependent on F2 force, or F1 is independent of F2? This formula is independent of F2, right? So it states that every charge in space creates a force at a point which is independent of the presence of other charges in the medium, and the resultant of the electric force is a vector sum of electrostatic force due to individual charges. So this is the superposition principle, which says that resultant electric force is the vector sum of the electric force due to individual charges, and that's exactly what we have done here, haven't we? The net force on this is nothing but the vector sum of F1 and F2. We added them, and that is the net force on Q, right? So you can write down principle of superposition. Fine, let's go ahead. Now two charges are there, Q and 4Q, and they are placed at x equal to 0 and x equal to L. Find where another charged particle Q is to be placed on the x-axis so that the net force at x becomes 0. So two charges are there, Q and 4Q, and I want to place where another particle of charge Q is to be placed on the x-axis so that the force on the charge at x equal to 0 becomes 0. So I want to make the force on this object 0, So as of now, if you notice that what is the force on this charge Q, it is because of this 4Q charge, it's a repulsive force because both are Q, so it's a repulsive force, let's call it F. So my charge at x equal to 0 is already experiencing a force F due to this charge, right? It's already under force. Now I want the force to be 0. So how can I make the force to be 0 on this? I need another vector which should cancel this force. So in which direction that force should be? So that it should be able to cancel this. It should be in this direction so that it can cancel this, right? So it should be in this direction, right? So to generate a force in this direction, what do I need? Where should I keep the next charge now? And all are q, q, 4q, and another, the third one is also equal to q. So where shall I keep that third charge, which is q again, on the left of q or on the right of q, so that the force is in this direction? It should be on this side, right? Then only it will generate this force, which is going to counter this force, right? And at how much distance, that I don't know. So let's call the distance y. Let the distance be y. While I know that this distance is equal to L, that is given to me in the problem, right? And let's call this green force F prime, right? What's wrong with this? Perfect. Okay, that way you can do it. Nice, awesome. So the knowledge can be fine, fine, perfect. Okay, so guys, what should I do to make net force 0? Tell me. For net force to be 0, F should be equal to F prime, and how much is F, guys? F is the pink force, no? So it is K Q into 4Q divided by distance, which is L square, must be equal to F prime. F prime is the force between them, which is K Q into Q divided by distance between them, which is Y square. And then of course you get Q is getting cancelled, and you get you get Y square is equal to L square by 4, which can also be written as 2 square, right? So from here you get Y is equal to L by 2. Okay. So I hope you guys understood this. Take this down. Right, so let's go ahead. magnitude of a vector. So let's say you have a vector ai plus bj plus ck. Magnitude of that vector is given by the formula under root of a square plus b square plus c square, right? And what's the formula for a plus b whole modulus? It is a square plus b square plus 2abc, where c is cos theta. And when theta is equal to 90 degree, mod of a plus b will become how much? This we don't need, we can forget about this part. Now tell me what is magnitude of a minus b? It is, that's a square plus b square. Instead of plus it becomes minus 2abc, and c is again, as you said, cos theta, where theta is the angle between a vector and b vector, right? Let's go ahead. Three charged particles, each having a charge q, are kept fixed at the vertices of a equilateral triangle. The net electrostatic force on any one of the charged particles is how much, right? So net force you have to find out, no big deal, right? So you got three charges on either of the corners, and you have to find the net force on any one of the charges, right? So let's do that. So we don't need the question now, right? The question is quite clear. You have got three charges, 1, 2, 3. You want a force force on any one of those. So for the sake of simplicity, I'm going to find a force on this charge. Right, let's find a force on this charge. Just for the sake of convenience, not even simplicity, convenience. I've already drawn the axis here, right? Okay, so here is the charge, and there are two charges here. One charge is here, right? So this will, and here is your this charge q, and I think all of them are identical, right? All are identical charges, I suppose. All are q, right? All are q, yeah. So see guys, q charge is here, then you got another charge, so that will apply a force on this charge in this direction, right? Call it F, and let's say this distance is L. So what is F equal to? K Q into Q divided by L square. F will be acting in this direction, right? Now there is another charge Q, which is applying a similar force F in this direction, right? And how much is that equal to? Well, that is also equal to K Q square by L square, right? And we've got two forces, and the net force will be the sum of the two forces, right? Now the interesting part is, what will be this angle? Equilateral triangle angle is 60 degree. That means this angle will also be 60 degree, right? And the resultant will be somewhere here. Yeah. So where was I? Okay, I'll use a different color. And resultant will be somewhere in between, right? Here will be a resultant, right? Let's call it F R, resultant force. And what is the formula, guys? There are two vectors, right? We just saw formula is F square plus 2F into cos of angle between them. In this case, what is the angle between them? 60. And you know cos 60 is equal to 1 by 2, that gets cancelled with this 2. So we get root of F square makes 3F square, which is equal to root 3 times F. And what is F equal to? K Q into Q divided by L square. That is your resultant force. Got it? So which option we are getting? Root 3 K Q square L square. Right on. Let's go ahead. So now these are all problems of various kinds. Let's do this question first. But we have done a similar question again, right? So this we done a similar question. So you guys try all these questions. We have done the theory for these, right? Let's do one or two more questions like this. Let's try this question. This question: where should a third charge Q be kept so that it remains in equilibrium? Or you know what? Do we? How much time do we have? We do have time. Let's do this part rather. Let's do this one. Sum of the forces with equal angle between adjacent and having same magnitude. What I mean is that let us say you have got so many forces acting here. You can see you got so many forces acting here. Each is F, right? My question is, what will be the sum of all these forces? What will be the net force, net force acting at the center? So you know this will cancel this one, this will cancel this one, this will cancel this one, right? All the forces will cancel each other. What will be the net force, guys? Net force will be 0, right? So when you have equal magnitude forces are acting here, when some of the forces with equal angle between adjacent and having same magnitude, the sum comes out to be 0, right? So I hope this part is clear. Okay, in that case, can you guys tell me, you here have to find the come on, not you, find the force on a charge, the charge kept here at the center. Find the force on a charge kept at the center of a equilateral triangle cause of the charges at the triangle, right? So what is the force on Q naught because of these guys, other three guys? What will be the net force on Q naught? That we have to find out. So how do we do that? So this is a Q charge, right? It will apply a force in this direction, right? Repulsion force F. Then you have a yellow charge here. It will apply a force in this direction, right? This direction. Then you have a green charge here. That will apply a force in this direction, right? So what will be the sum of all these three forces, guys? Again, you can see that they are equal magnitude forces, right? Equal magnitude forces, and the angle between them is also equal, isn't it? 120 degree, right? 360 by 3 is 120, you know. So what will be the sum of net force will be how much, guys? Net force will be again 0, right? Net force will be 0 in this case also. What about the net force? Here was also 0, right? What was the reason? So reason is written here: sum of the forces with equal angle between adjacent and having same magnitude is equal to 0. Don't put a question mark, write down equal to 0. So that statement you can write down, and that is why the sum is coming out to be 0. So take that statement down, that's very important statement. Then with that, let's move ahead. Here it is also coming out to be 0. Now what about this case? What will be the force here? Find the force on a charge kept at the center of this square. Net force on Q naught will be how much, guys? Tell me. The way we saw here, no? Here it came out to 0. Equal forces and having equal angle between them, sum comes out to be 0. Right? Same thing here also. Equal forces having equal angle. You see, guys, the angles are equal, no? This angle, this angle, this one, this one, this one. All the angles are equal, right? So net force comes out to be 0. You know, here also it comes out to be 0. Here we have to find out. What do you think? What will be the answer, guys? What will be the net force on the middle charge Q naught? Will it be 0? Let's say this green charge. What is it doing? It will apply force in this direction, right? Here. Call it F. Then talk about the next charge, this fellow. We'll apply force in this direction. Call it F. You know. Then this fellow will apply force F. And similarly, this fellow will also apply force F. And it so happens that all the forces are having the same magnitude. Why? Because distance is same, you know. So let's write down value of F. This will be how much? K Q into Q naught divided by distance. Let's say distance is how much between them? Let's say this distance is B, right? So divided by B square. You know? And all the distances are B, guys, isn't it? Like if you check this distance is how much? That is also B, right? Okay, so F comes out to this K Q into Q naught. Q naught is the charge at the center. This charge is Q naught. And K comes, force comes out to be K Q Q naught divided by B square. Got it? And all the forces are of having the same magnitude, right? So I'll again, all F are equal in magnitude and have same angle. Is it true? Yes, all the angles are 90 degree, right? And have same angle between them. So net force is equal to 0. Again, net force is 0. Net force is equal to 0 on which charge? On the middle charge, Q naught. Right? Done. Let's go ahead. Now same question, but this time instead of a square we have a hexagon. So we have a pentagon, I suppose. 1 2 3 4 5. Yeah, pentagon, not a hexagon. So again you have to find the net force, right? Net force on Q naught. So how will you do that? What will be the net force on Q naught, guys? Will it be 0 again? Yes. Why? Because this will apply a force in this direction, this will apply a force in this direction, this will apply a force in this direction, this will apply force in this direction, right? And this will apply force in this direction. So how many forces are there, guys? 5 forces, and yet again the angle between them is how much? Angle between everyone is, let's say, theta. So this is also theta. All the angles are same, you know. And again same angle and same magnitude. That tells me net force on the center charge. What is the value? Q naught. Center charge value is Q naught, you know? On Q naught. You see Q naught. Q naught is equal to, yet again it's coming out to be 0. Wait, take it down. And that will be all for today.